So this will be the last section, section 10.4, which is on shifted conics. So we're still doing parabolas, hyperbolas, and ellipses, except for now, they're not going to be centered about the origin. Right? Right. So let's look at some examples here. So this case, we have in terms of an ellipse, and given information in terms of the vertices, we have minus 7, 3, 3, 3. Foci are minus 6, 3, and 2, 3. Right? Okay. So we have in terms of that's our given, right? Now we can see here that the y coordinates are all the same, which means then that this is going to be an ellipse running in that direction, right? Right. So we need to find the center of our ellipse. So we can do that from our vertices. Remember, the vertices are at the endpoints of my ellipse. So my vertices are here and here. And so we can find the center there. And so the H is going to be a 3 minus a minus 7 over 2. And so this is going to be 5. Right? And the K, right, is actually to be 5 is the middle point. And sorry, that's going to be 5. And so the halfway point is 5. And so minus 7. Let's do this again, right? Let's try this again. So minus 7 plus 3, this will work better. I want to do the other step. And this will be a minus 2. Okay, do it that way, it'll be work better. Wanted to do a 2-step process. And then, of course, the K is 3 plus 3 over 2. And, of course, that's just 3. So my center is at minus 2, 3. That's my center. So for this shifted conic, which is an ellipse, it's going to be in this form, x minus h squared over a squared, y minus k squared over b squared equals 1, right? And so we now know the h and the k. This is my h. This is my k. So we now have, this is going to be an x plus 2 squared. This will be a y minus 3 squared. So we have those parts of this. Right. And let's see, the length of the major axis would be the distance from here to here, right? And so the length of the major axis is going to be 3 minus a minus 7, which is 10, right? And so that would mean, so 2a equals 10. And so a is 5. Right? So we know a is 5. So that means we know that this is now going to be 25, because that's a squared. And then we can get the distance between the foci, so these numbers. And so for the foci, we have 2 minus a minus 6, which is going to be 8. And so C is going to be 4. So we know A, we know C. Of course, we now need to know B in order to get that number in here. And we have that C squared equals A squared minus B squared. So this is going to be 4 squared equals 5 squared minus B squared, 16, 25. So a minus 9 is a minus B squared. So B squared is 9. And we have our equation of our ellipse that is centered about -2, 3. Right? So that would be an ellipse. Let's do another one. In this case, let's do a parabola. Right? And for a parabola, there's, again, depending on which way it's running. And let's actually get both forms up here. And again, it will be part of the notes. It will be part of a handout I will give in class tomorrow. And so, and so you have in terms of this formula. And then the other one is this form. So those are the two forms we're using. So let's do an example here of a parabola. Right? Right? So this time, the given information is, again, they're going to tell you what it is, okay, in terms of these type of questions. They tell you parabola. They tell you the vertice is at -3, 5. And the directrix line is y equals 2. And so this tells me that this is an x squared parabola. So in terms of this one then, right? So we need to find our P, and P is going to be 5 minus 2, so P is 3. The H and K barely correspond to my vertex in this problem. And so this is going to be x plus 3 squared, 4 times P, so 4 times 3, and then y minus 5. So x plus 3 squared, 12 times y minus 5. And we get our parabola. Right? So let's see, we did an ellipse, we did a parabola. So let's do another example, this time one of a hyperbola. And so again, so this time they tell you it is a hyperbola. And the center is at -1, 4. And V1 is at -1, -3. And V2 is at -1, 11. And then the foci, F1, -1, -5. And then F2 is at -1, 13, right? And let me write those forms up here for my hyperbola. And so my two forms are this. That's the one. And then the other one is y minus k squared over a squared minus x minus h squared over b squared. So those are the two forms, right? In terms of a hyperbola. Right? So in terms of this one, you notice that my x numbers are all the same, which means we're going to want in terms of this form of my ellipse. So we can find in terms of my numbers, right? So my A is going to be 4 minus a minus 3. So A is 7. Right? My H and K correspond to my center point. So this is going to be y minus 4 squared over 49 minus x plus 1 squared. Right? So we got that part so far. So that means we still need to find the value of B. Right? And then in terms of my C, for my foci, we have C is going to be 4 minus a minus 5. So that is 9. And then for hyperbola, we had c squared equals a squared plus b squared. And so we have 9 squared, 7 squared. So 81, this is 49. And so b squared equals 32. And that's the number that would go in there. Right. Right. So the other way you can see an equation in terms of a conic is this one. Okay. And we'll do an example of what you would do when it is given in this form. And so this is the general equation. And so you have ax squared plus cy squared plus dx plus ey plus f equals 0. Right? Right. And so A and C are not both 0. Otherwise, we don't have in terms of a conic here. Right? And then, depending on what you got, it tells you a few things. Let me write those down here. And that is A, you have a parabola if A or C is 0. Okay? So that we would just have an equation either just in terms of x squared or in terms of y squared, which would be my parabola. 2 is we would have an ellipse if A and C have the same sign. Same sign. Oh, there we go. Okay. Or it's a circle if A equals C. And then thirdly, we would have a hyperbola if A and C are opposite sides. Okay. Okay. All right. So we have our general equation. Then depending on the values of A and C, we could have a parabola, an ellipse, or an hyperbola. So let's go through one where the equation is given in terms of this form. So I'm going to get rid of all this, make some working room. And we're going to start with this, right? So we have 4x squared plus 25y squared minus 16x 200y 316 equals 0. All right. Let's see. A and C are both positive. And so that tells me we're going to have an ellipse. So now let's see if we can arrange this into an ellipse equation, right? So let's first do some regrouping here. We got a 4x squared minus the 16x plus the 25y squared plus the 200y. And I'm going to take the 316 to the other side, all right? All right. Well, now we got to do some completing the square stuff in order to get our equations. And so for do that, we got to first make the number in front of the squared terms of 1. So we'll take a 4 out. So it'll be x squared minus 4x. And then here we'll take the 25 out. Right? So we get that, right? And now we'll do some completing the square stuff here. And so here we have 2b equals a minus 4, which means b is a minus 2. And then here we have 2b is 8, which means b is going to be 4. Right? And again, this is all based on my completing the square stuff, which said we're going to have in terms of x squared plus 2bx plus b squared. That was my completing the square stuff, right? So that would mean this, if I look at this, would now be 4. This would be x squared minus 4x plus 4. This would be 25 y squared plus 8y plus 16. Okay. But now we need to look and see what we added. Well, here I added a 4 times 4. So I need to add that over here. Right? And then here I added a 25 times 16. So I need to put that over here. Right? 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 So let's do this now in our factored form. So this will be x minus 2 squared, 25, y plus 4 squared. And if you do all that, you're going to end up, this is going to be a plus 100. Right? And remember, we want that in terms of an ellipse, we want this to equal 1. And so if we divide this side by 4 times 25, divide this by the 4 times the 25, divide this by the 4 times the 25, we now end up with x minus 2 squared over 25 plus y plus 4 squared over 4. And this will be 1. So we have our equation in our usual form. Right? And now that we have it in that usual form, let's see if we can figure out in terms of our, where are we centered at? Where is my vertices and foci and all that good stuff? So let me move this over a bit. All right. All right. So if I look at this equation, let me rewrite it up here. Okay. All right. And so if I look at this, we know that a squared is 25. which means A is 5. B squared is 4, which of course means B is 2. We know that the center is at 2, -4. Okay. And then we can find our C squared. And so C squared is going to be 25 minus 4, which is 21, which means C is the square root of 21. Okay. Okay. Oh, let's see what else we got. The horizontal length is 2 times A. And so this is going to be 10. The vertical length is going to be 2 times B. That'll be 4. Right? So my center is at 2, -4. Right? And now to get in terms of the vertices, we need to add in terms of this 5 on either side. So B1 is going to be 2 minus 5, so -3 minus 4. And B2 will be 7 minus 4. And then my foci are going to be in terms of this square root of 21. And so we're going to have 2 minus the square root of 21, -4. Make this better. 21, okay? And then 2 plus the square root of 21, -4. Right? So that is everything in regards to this equation. So again, we took it, we went from this form, right? So we want to regroup, get the constant to the other side, right? And then in terms of this, we need to do completing the square, which means whatever number is in front of your squares, you need to factor out because this number has to be a 1. And then we can find our B by doing that. And then we got, this is where it would be if I put that term in there. And whatever we add on this side, we had to add onto this side. So we had the 4 times the 4 over there, and the 25 times 16 and added it over there. Okay. And we got to this, and then I said, well, again, we got to divide because we want this term to be 1. So we divided everything by the 4 and the 25, and we ended up with our equation of an ellipse in the usual form. Right? And that will conclude this video.